just received the update that Dr. Mego Pinandito is going to share the keynote presentation related to our theme also. So to Dr. Mego Pinandito, please, if you are ready, Pak, time is yours.
Okay, it's already open. Yes, thank you very much. Yeah. Yeah, regarding to the what would like to deliver today, I just try to share this little bit. Oh, sorry. Yes. It's already displayed well.
I think it's still waiting for the screen.
Not yet?
No, not yet. I think it's not yet pop up into our screen.
Just
stop. Yeah, maybe we can try again once again. Yes, now we can see. Yeah, it's clear.
Okay.
Thank you, Pak.
Yes, thank you very much for just want to explain about the National Research and Innovation Agency. We call in Indonesia is the BRIN. Regarding to the future research and innovation, that is including the mechanism and also how to deal with all of the activities of research and innovation in Indonesia. First, since the April 28, 2021, this year, we have the special government body directly under the president. It is not a ministry, and also we are not. BRIN is the non-ministerial government institution. So BRIN is already discussed in the cabinet that they are already direct responsible and also ordered by the president. And again, if we look at the Indonesian now, BRIN is trying to integrate all of the resources, including the human resources, infrastructure, and also the national budget. Of course, not only with, we know like Lapan, LIPI, PPPT, or Batan in Indonesian language, that is including the National Institute of the Aeronautics of Space, in the Indonesian Institute of Sciences, Agency for Assessment and the Application of Technology, and also National Nuclear Agency. But of course, it is including the about 44 government research institutions across the ministry and institute. So regarding to this one, it means that in BRIN, we are covering almost all of the field of the research and innovation. And it will be implementing as soon as possible. We try to start after the day after the inauguration of the head of the chairman of the BRIN, but like August and 2 days, we are almost running with all research and innovation. So in the case of this, the mandate of the BRIN drastically try to, example, to encourage and also to coordinate all of the all of the resources, so that we can updating and we can also the increase of the critical mass of research and research resources in Indonesia. And along this the aim, of course, we are trying also to attract young talents on research to join and to contribute any research activity in Indonesia. It means almost the master and the doctor degrees would be better, and also try to get more and more in talent. And again, we cannot doing it together only with Indonesia, but of course, we try to support, to get supported, and to deliver the global engagement and collaboration in spite of the speed up of the technology, knowledge, and transfer to the research collaboration. And as you know that the target means we can try to, one is to how to make the collaboration in the global standard research ecosystem, that is including the academia, industry, also the community and government, and also in focus on the only three, but it is not a small tree, but a very big tree, the digital economy, the green economy, and the blue economy. That is including how the digital, I think, for example, in supporting, for example, smart farming, and also how to engagement the collaboration with such kind of the industry. And the target, as we can see, that specialists in the focusing of the research try to increase the value added in the local natural resources. It means that we can also trying to make the start of the research from the local product or the local things that we are already announced. But of course, because of Indonesia have not only the biodiversity, but of course with the geography, diversity, and also art and culture, it means that we have more and more in trying and to offer the international collaboration. It makes Indonesia as the global platform for the natural resources and diversity-based research, including this one, facilitating, again, integrating the research and innovation, especially in the infrastructure resources, will be the enabling for the national industry and business player to conduct the research and development-based product development, and by providing the platform for the talent human resources in Indonesia. It means that we have to have international collaboration more and more. So I think with this conference, with the international conference, for example, with conference of the Lignocellulose, and also the International Symposium for Sustainable Humanist Field, it will be very important to get the engagement of this the field. So I think this is what have been done by the government regarding to the regulation. It started with the national policy, the research and innovation law is in 2019, and also with several supporting or driving regulation, including the local content. We call the TKDN. The government also set some procurement regulation. It is almost with the priority in the local product, and also using the electronic catalog for innovation, and also some incentive, the low tax incentive, for example, super tax deduction for business who are doing research together, and also with the incentive on inventor. So if you like to the, I think all of the inventor of the research are also hoping that more and more in the passive income. So this is also the important one, that the incentive for the inventors are also supported, have been and supported by the government. So including the national talents management and also open research infrastructure, we are offering the international collaboration to come to Indonesia, and also to use all of the facilities, and of course, together with the scientists from Indonesia to do research and innovation. Not only with the infrastructure in the land, but also we are trying to support for the oceanic activities. We set several research vessels. I think in the future means that for next year or the next 2 years, with the new research vessels in Indonesia. Of course, all of the data, including the raw data, are obligated to set with the primary scientific data repository, so we can use all of the data by, of course, by some of them, so that we can share what the important thing, and also to discuss more and more in data analysis and utilization. And this is just to show that by the new policy, we support the science-based policy, as we know that all of the policies set by the ministries are also need to be, for example, first is coming from the science base. So we are doing together first with the ministry and institution on the government, and also to put some quantitative and quantitative analysis, for example, to support the science-based policy recommendation at the national and also the sectoral level, because now in BRIN, we are integrating and coordinating almost all of the research and innovation activities. And finally, it would be in the best one to have the public support, so that you know that if you look at the policy, it comes and it the aims is to come back to the society. So this link, it will be very important in the future. And as we know that we are trying to open the facilities, and also to get together to utilize the researcher and also the scientists in Indonesia. There is also the open program to use this kind of the BRIN belongs, for example, in the infrastructure, in the talents, and also for using some budget coming from BRIN. And we know that the academic in the universities and such kind of the professional program in some polytechnics and so on. We are also together with the business player. We use such kind of the infrastructure and academic together to support the industry. It will be the best one. And of course, after that, we try to have new startup, even is coming from the print technology and another innovation. But of course, they are also enabling to use their own technology, their own innovation, to use and to together with BRIN to support. And of course, again, global network is the key point that we cannot develop. We need, for example, as today international conference and also symposium, get together with the global network, get together in the international collaboration to share the innovation, to share the publication, so we can update our states, our position in global. So we know that it is very important to know what kind of the activities and what kind of the thing that we do is, again, if you look at the today activities today regarding to the Lignocellulose, we know that several are also coming from the forest, coming from the resource or the resources from the Indonesia. And again, improving to the research and innovation ecosystem in Indonesia, we try to make such kind of the collaboration hub and enabling the multi-local and global stakeholders, in particular to local industry, to do the R&D in the platform. So if you look at this one, I think using the open platform with including the human resources, the infrastructure, and network may get more and more in the doing the scientifically well proven and also comply with the regulation. So finally, we will have such kind of creative economy. Here, regarding to the global collaboration, again, this is not only the academic sites. The global collaboration are including what for example, the topics coming from, and also who will get together with our researchers, because BRIN has already set some program. For example, in the capacity building, we will recruit more and more at the PhD degrees, and also we setting the PhD by research program, so that they not need to get such lecture in the university, but of course by international collaboration, we have also with Japan, for example, we have Rompaku program or Sandwich program. Even there is also some established engagement with several universities in the world to support this program. And also for the postdoctoral, it is also enabled to set somebody who will get this postdoctoral program into print. And the other things is regarding to the mobility program. We can also invite professors from university in global, for example, to visit and stay several times. That is including, for example, to 6 months or a year, to do research together, to give the lectures in university or in BRIN, for example, and also to visit by the visiting fellows. This is including researchers from abroad, from international universities coming to BRIN, to Indonesia, again, to doing research together. Then the other thing is about the research assistantships. It is also possible to send our research to universities in global, in several countries, and also doing research together, okay, not only with the university, but also with the industry in global. This is the right side. The left side, it means that in the industrial activities, we are offering this open platform to the industry. They can use this facility as part of their industry, they corporate, and they can use this facility to, for example, to develop the new product, to develop more and more efficiency and also effective product in the future by reducing the investment risk on research and development. Because we think that if you asking the industry to doing research by, for example, to develop infrastructure for the research, and also with the other things, it is again will make some cost, and to the risk of the investment will be bigger and bigger. So in the case of the industrial supporting from BRIN, we try to, again, to support them by developing the new business models, increasing the economic scale, and also transforming what have been done in the research activity into the new business. And if we know that, okay, just see, BRIN and propose and the team for the, we are trying to have to host the G20 in 2022. And of course, it is not only that year, but of course, you know that doing research should be continuous, sustainable activities. So we are setting the digital green economy research and innovation, setting already with the biodiversity research and its value-added development, and also coping with the COVID-19 pandemic's development using the research and innovation on the medical and also the public health. Fourth is about the space technology. We are also look at the space technology is the what we call that, one of the highest technology that's coming from several technology, materials, energy, and also with the telecommunication system and some rather in, and also with the scientific collaboration research engagement, ring with the human resource development and the technology for disaster management and also mitigation. So in the case of this one, again, we are trying to get more and more in collaboration, first with the research and innovation working group meeting, and with the second meeting, and also we have planning to have the ministerial meeting on research and innovation, of course, with several countries that is already in.
Tabung gas saja sekarang sudah 160.
And also with the Research Innovation Expo is back-to-back to ministerial meeting on research and innovation. And of course, finally with the G20 meeting, and of course with the G20 Space Economic Leader meeting. This is also coordinated by the BRIN and the Institute of Aeronautics and Space. I think this is what we'd like to deliver in this opportunity to share, and also to asking all of the scientists who been participate in this international, the two international seminar and conference that BRIN will give and support the collaboration, as well as what you can share into these activities. And of course, not only with the researchers coming from Indonesia, we would like also to invite the researcher, the professor from our neighbor countries, countries who will again participate in this conference to come and to have such collaboration with Indonesian researcher, and to utilize all of the, for example, in digital, blue and green economic research and innovation, and by using and utilize all of the activities and the infrastructure in Indonesia, so that the scientific collaboration research engagement can be performed well. I think that is the important thing that BRIN will offer. We call the global platform regarding to the digital, blue, and green economy, that these three pillars for Indonesian thinking in the future are very related to this international conference and on the Lignocellulose, and also in conjunction with the symposium for the sustainable human sphere. I think that's all my presentation. Hopefully that you are able to understand and get more and more in the future collaboration with Indonesia. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Dr. Mego Pinandito and also to Dr. Franciscus as our keynote speakers for today's session. As today's agenda, we will continue with the parallel sessions for the invited speakers together with the presenters. And so therefore, I would like just to remind everyone that we have 4 breakout rooms, namely by PS1 for the biomass conversion, PS2 for bio-based smart material, and PS3 for the forest environment, and PS4 for the hybrid topic of forest and environment, enhancing mitigation for climate change, rather and atmospheric science and socioeconomy and SDGs. So now maybe I will guide you how to join the next session. So if you can see, there is an option of breakout rooms that you can see in the below of your Zoom meeting screen, and you can click, or there is an option of more that you can also click and choose the breakout rooms options. And there will be the join options in the right side of the breakout room's name. And you can click the join options there. So all the breakout rooms are open to everyone who wants to join any sessions. You can also always take a look at our program book for the detailed schedule of each session. And the last announcement, so the link for the attendance will
Recording in progress. Recording in progress.
Okay, so for everyone, those of you who are still in the main room, I will guide you once again how to join the breakout rooms. We have 4 breakout rooms of PS1 for the biomass conversion, PS2 for the bio-based smart material, PS3 for forest environment, and PS4 for the hybrid topic. So you can always click there is an option of breakout rooms in the below of your Zoom screen, Zoom meeting screen, or you can also click more options and choose the breakout rooms options. And once you click the breakout rooms, there will be another options pop up of 4 breakout rooms that I just mentioned. And you can click the join.
Recording in progress.
Session will be doing live, so you can use the raise hand button, and then we will call your name, and please open your camera and unmute. And because this session is online, so please just grab your snack, grab your water, so please stay happy and hydrated. And this session is consisted of one invited speaker by Dr. Professor Peter Spatel from Eberswalde University, Germany, and also will be followed by 4 presentation and then we will have lunch break. And in 1:30, we will back again for the afternoon session for 4 more paper presentation. So the confirmation of attendance has been shared in the chat room. So while waiting for the few more presenter, just please fill the link in the chat room. Thank you. Oh, there's probably there. It's gonna be a technical glitch in 1 second.
Recording in progress.
Halo Bu Penny, MC, boleh bertanya?
Aku lagi moderator, balik lagi.
Excuse me, participants.
Oh, yes,
could
sorry.
you please use English? This is an international event, so please address everything in English. Thank you.
Okay, thank you.
Yes, thank you everyone. We would like to just apologize and please kindly wait because right now we will also open again the breakout room. So I think right now I can see the join options in the breakout rooms. So right now you can click again the join options in the right side of the breakout room's name. So, and I can see now the more of the participants who have already assigned.
Recording in progress.
Okay, Assalamualaikum warahmatullahi wabarakatuh. We will officially begin this session. Good morning, everyone. My name is Apriwi Sulfitri. I'm the moderator for today's session, and I welcome you to the para session 3 that focuses on forest and environment. I'm here with the co-chair, Mr. Dana Sudaruka Adi, and for the best quality video, we recommend you to use any listening devices. And also, this morning session will be started by an invited speaker and followed by 4 presenters before lunch break. So let's start our session by listening to the pre-recorded video of our distinguished speaker. He is Professor Dr. Peter Spalteraf. He's a professor for applied silviculture in Edinburgh University. And at the moment, he is internationalization officer at his university and in charge of climate change with the German Forestry Association. So IT team, please play the video number 300.
Good morning, ladies and gentlemen. It is my great pleasure to give this talk at your conference. The title of my talk is Climate Smart Forestry in Germany. I will introduce my talk with some slides of past extreme climatic events in Germany, such as, for example, the extreme storm Lothar in 1999, which created more than 40,000 hectares of clear cuts in southern Germany and a lot of damaged timber. This is a picture of the recent spruce decline area in central Germany in the Harz Mountains, where thousands of hectares of Norway spruce stands died due to a heavy drought period in 2018 to 2020. Another area of disturbance, increasingly important in Germany, is forest fire. On this slide, you can see a large forest fire with damaged pine trees south of Berlin, where on 300 hectares of contaminated land with munition, so a former training area, a forest fire occurred and damaged a large part of the forest. Last but not least, an impression of a quite near natural forest stand near my university town, Eberswalde, with oak and beech, where a significant number of the old oak trees died due to drought stress. Yes, ladies and gentlemen, I'm very delighted to give this talk to you. I'm coming from Eberswalde. Eberswalde is in northeastern Germany, as you can see, near the German capital region. And I'm a forester. I was graduated at Freiburg University. The outline of my talk is I will talk about the damages and the forest decline phenomena in Germany recently. I will address the impacts of climate change. I will go to mitigation and talk about forest as carbon sinks. I will highlight some aspects of forest adaptation to climate change. And finally, I will outline the concept of climate smart forestry in Germany and what is the current state of CSF. Let's go to the climate change magnitude and impacts. On this slide, which was compiled by the Federal Thünen Institute, which is located at Eberswalde campus, you can see the forest damages in Central Europe 2018 to 2020 concerning the major tree species Norway spruce. And you can see the slides, the figures of Germany, where 178 million cubic meters of Norway spruce was damaged. This represents an area of clear cuts or damaged forests of more than 280,000 hectares. The situation is quite comparable in some neighboring countries of Germany, where we have a high amount of spruce forests, such as in Austria or in the Czech Republic. But not only spruce is heavily affected, also other major tree species such as oak or beech or Scots pine are heavily affected by these cumulative disturbances. Now, what about the climatic situation in Germany? What has changed? We see changing mean temperatures, as you all know, and more extremes. So more droughts and more high temperatures, so-called hot droughts, and we have a accumulation of drought years in the recent past. What we also see is a negative climatic water balance in the vegetation period nearly all over Germany, and the soil water in the winter times cannot be refilled. That is a huge problem. What we see, nevertheless, is that cold extremes still remain. So we still have frost events, which is important for the adaptive capacity of the forest tree species. So the question is whether is this a new climate or whether it is a kind of subtropical climate, what we recently see in Central. Let's look at a more global view and highlight the planetary boundaries concept, where stressors are identified and boundaries which are surpassed are also identified. And the group of researchers who worked on this global boundary concept stated that among the 10 stressors identified, 4 boundaries are already exceeded, and that is also relevant for Germany. So it's the weather extremes where we will focus in the lecture, and then it's fire, it's overuse and deforestation, and it's the invasive species topic. So what about drought stress, the impact and responses? So drought stress can lead, of course, to an acute damage, but after a heavy drought stress, tree species can also recover. They can even adapt to the new situation and acclimate and come back to a kind of normal range of their physiological parameters. On a long term, after drought, there can also be a decline process. So we can have mortality, or the species can recover. And the drought stress phases are combined or related to the production of substances which can be used as bioindicators, such as proline, for instance. Drought stress can lead to two phenomena. First, so-called hydraulic failure. If, for example, tree species do not immediately close their stomata after the drought stress event, due to a high stress situation, the water system of a tree can collapse, which is called hydraulic failure. On the other hand, species which immediately respond to a drought stress by stomata closure, so-called isohydric tree species, an example is oak or spruce in Central Europe, these species can lack of meta production due to carbon starvation. So that is the second pathway after drought stress a tree can have. Finally, after drought stress, which can be an important triggering event for a so-called decline process, and reinforcing in many of these decline processes of our major tree species can be biotic damages by insects, for instance. So the spiral model of tree decline explains quite well the mortality process of different tree species at the moment. What about the response of the forest ecosystem to climate change? So first, the productivity is already affected. We know that in the second half of the 20th century, productivity of the Central European forests was increasing. This was a landmark study done by the European Forest Institute, EFI. But the situation changed. We see from stem analysis on many tree species that after a drought or a cumulative drought in several years, growth is declining. We can see it very clearly in the figure of a spruce tree 2003 in a very severe drought year. The tree ring is quite small, and even smaller in the year 2004. So what we see, especially in warmer lowlands, that the productivity of our forests is already affected and maybe negatively affected. First, modeling attempts underlie this effect. Another point of response of our forests due to climate change is the increase of salvage cutting. So the increase of damaged trees. In the background, you have a European graph with some figures of salvage cutting, which increased very heavily after 1950. And the figures for Germany recently from 65 millions of cubic meters of annual cutting, 45 millions were salvage cutting, and the cause of the salvage cutting is to 70% insects and 15% storm. Another point of response is the range shift of species. We can expect, and in some areas in Europe we already can observe this. For pine, the right photo, which is heavily affected, so Scots pine, Pinus sylvestris in Germany since several years. Scots pine is dying and may be substituted by broadleafed tree species of the natural forest cover. And again, the Harz Mountains and the spruce decline. Spruce, a very risky species in Germany in the lower elevations below 600, 500 meters above sea level. Spruce will somewhat disappear in these warmer lowlands in Germany. And we will have to recognize potential economic losses due to a species shift in Europe, which can be expected. In a nice study done by Mark Hannewinkel and colleagues, this shift to more Mediterranean and sub-Mediterranean, especially oak species in Europe, leads to a loss of expected forest values between 14 and 50%. So what is climate smart forestry? Climate smart forestry, ladies and gentlemen, is not completely new. but climate smart forestry has a specific emphasis in sustainable forest management on the mitigation and the adaptation of our forests to climate change. So there is a specific focus in climate protection and in adapting our forests to climate change so that we may have more resilient forests in the future. That is climate smart forestry. Let's go to the climate protection issue. So with forests in Germany. So are forest landscapes in Germany carbon sinks? Yes, at the moment they are. You can see on the slide that especially younger forests, but also mature forests to a certain extent, do sequester carbon. On the other hand, we have carbon release due to forest fire and due to harvest. So the forest landscape oscillates around a trend curve, which in Germany is still positive. So the German forests still do contribute positively to carbon sequestration. What is the system about in carbon sequestration in Germany? We have two levers. We have the sequestration lever, which is composed out of the forest and the extended forest sink, which is the harvested wood products. And we have the substitution lever, which is composed out of the product substitution and the energy substitution. And we will see the figures later on. Now, what about the forest as a potential carbon sink? And in Germany, the forest is luckily still a good carbon sink. This has to do with the increasing standing volumes in Germany in the last decades, which can be seen also in the national forest inventories in Germany. So the standing volumes are increasing and are sequestering more and more carbon every year. So we have a significant forest sink in Germany every year. But this forest storage, of course, is not infinite. So the stocks of our forests, they are somewhat limited because forests with higher standing volumes are increasingly more vulnerable. We know this from many studies and monitoring in the forest health monitoring in Germany. So there is a kind of limitation, and we can see realistic storage rates, for instance, for beech of 1 to 2 cubic meters per hectare and year. What about the product storage and substitution effects? So harvested wood products can store additionally more carbon, and the use of products instead of more CO2 intensive products can significantly substitute CO2. You can see the substitution factors. Again, also with energy substitution, of course, energy use of wood should be done after the cascade use. So first the material use, and then finally, after having several times used the timber, it can be burned also. And with burning, we can also substitute some CO2. So the sink capacity of German and also European forests, this is the graph for that fact, is still there, is relevant, but it seems to be that the carbon sink of our forests is kind of saturating, so it may be transient because European and German forests are becoming older and older, and the increment rates are declining or are stopping to increase. Yeah. So that means that the carbon sink can be some. What are the risks of storing carbon? I already mentioned. Storing carbon in forests, so with high standing volumes, is not free from risks. And there is plenty of studies showing the vulnerability increase with tree age. And there is also the fact that many studies show that managed forests where wood utilization is taking place are more resilient than unmanaged forests. That leads us to the potentials of using the forest system as a carbon storage. This is climate smart forestry. So to convert storm-prone forests to optimize silviculture for a more carbon efficient management, to reduce disturbance intensity, and also to conserve high carbon stocks in set aside. This is the situation for Germany at the moment. So Germany is sequestering in their forest system more than 11% of the annual CO2 emissions. So forests and timber products do contribute here significantly. Let's go to adaptation. If we look at adaptation of our forests, we have a kind of opportunity windows in the initial stage, especially of forest management, where we can introduce new species, where we can work with different provenances, where we can create mixed resilient forests. And there is some options in the intermediate stage of forest development, where we can work with modified thinning regimes. And finally, also the rotation question and the time of harvesting allows us to adapt our forests in a certain. In an attempt several years ago to check whether close to nature forestry, which is maybe the most popular silvicultural approach in Central Europe and in Germany, whether close to nature forestry or continuous cover forestry is compatible with adaptation principles. We compared these principles with close to nature procedures. And there is a high degree of compatibility in terms of species richness and structural diversity as a major principle of close to nature forestry, the maintenance of genetic diversity of stands, and so on. So this is quite a suitable system for adapting our temperate European forests to climate change. An important feature of such a system is the functional diversity of the stands, which have to be emphasized. So if a forest stand has a mixture of tree species with functional diversity and a high redundancy of this diversity, then after disturbance, a species which may be lost can be compensated by other species. Assisted migration, so the planned migration of tree species or provenances into a climatically more suitable region, is another option to bring in new traits of new species or provenances into a forest ecosystem. And there are several possibilities of assisted migration of tree species. It's the population migration within the range of a species, it's the range extension, and it's also the species migration into another area far away from the natural occurrence area of a species. And I gave some examples of oak in Europe, where already a kind of migration has happened in the past. Just remember the introduction of red oak, a completely alien species for Germany, from Eastern North America to Germany already since. So is the introduction of these non-native species a success story? Yes, partly we can acknowledge this. So non-native species have their pros. Of course, there are risks which we have to take into account, such as invasiveness, for instance. And we have a good record with our permanent sample plots in Germany of successfully introduced alien species, such as Douglas fir, of course, with a small share in Germany of 2, 3, 4% of the forest area, depending on the region, then red oak, western red cedar, Japanese larch, and grand fir. And many other potentially suitable species from abroad are investigated at the moment. They could also enhance the resilience of our forests if they are integrated to a smaller extent, of course, and not in pure stands. Another last point to increase the resilience of close to nature forests in Germany, of managed forests, is the inclusion of features of old growth forests. So such as large trees, old trees, so-called habitat trees, and deadwood, be it snags or coarse woody debris, which enhances the diversity of forest ecosystems in terms of insects, in terms of antagonists, of potential damage agents, and which makes the forest more healthy as a whole. So this is an important procedure to improve the forest resilience, and is in line, of course, with nature conservation requirements. And finally, we have to adapt this management procedures, ladies and gentlemen. So we cannot rely on a strategy which we take or which we implement today for several decades, but we have to check frequently, maybe every 5 to 10 years, our outcomes of the ecosystem and adjust the management procedures according to our goals. And maybe we have also to check our goals and adjust them also. So adaptive forest management is essential, is indispensable. Just one remark, the question which is under debate in Germany is, are forests without any management the better forests in terms of resilience? We think no. We think we have a lot of indications that carefully and sustainably managed forests lead to a higher resilience of the forest ecosystem. So what is the current state of climate smart forestry in Germany? We should not neglect the mitigation potential of forests and the wood use. Forest conversion and reforestation after damage are essential for enhancing the adaptive capacity of our forests. And finally, a multifunctional approach may be kindly adapted in the form of a triad approach, so to lay a specific emphasis on specific areas of the forest with respect to the required ecosystem services is, in our opinion, the best approach for climate smart forestry. And with that, I thank you very much for your attention, and I am looking forward to your questions. Thank you very much again. It was a privilege to give this talk at your conference.
Okay, ladies and gentlemen, we just watched the pre-recorded video of Professor Spatter's presentation. Unfortunately, until this moment, apparently he is unable to join us today. But on behalf of the committee, we thank him who took time to prepare his lecture prior to this event. And I understand that you surely would love to ask a few questions. So we will share the contact information in the chat room, so you may address your question privately. Now, let's continue to the parallel session. We will have 4 prepared presenters in this morning session. And now let's, and the first presenter is Professor Dr. Wahyu Dwianto from Research Center for Biomaterials BRIN. I hope he is already with us today. Professor Dr. Wahyu Dwianto, please open the camera.
Yes, I already. I think.
Okay. Professor Wahyu Dwianto is a researcher in Research Center for Biomaterials BRIN, and he got his master and degree from Kyoto University, and he published almost 140 publications, consists of journal, proceedings, and also he is actively involved in Indonesian Wood Research Society. And currently, he is a chief editor of Wood Research Journal and chairman of the GSPS Alumni Association of Indonesia since 2019. And also, he received a token of the Technology Transfer Award from Indonesian Institute of Sciences in 2017. Now, let's hear the presentation. IT team, please play video number 301.
In this conference, I would like to share our research result with the title Change in the Characteristic of LIPI Fast-Growing Teak Wood at Different Age and Growing Size. These research were partly funded by the Japan Asian Science and Technology Innovation Platform, or JASTI program, in collaboration with Professor Junji Sugiyama and Associate Professor Aki Sakitamori as the leader of JASTI project, entitled searching and characterization of economically potential utilization of tropical wood species, and development of eco-house concept for a traditional modern combination design of wooden house construction, respectively. Teak wood is a high-quality major commercial timber, having good strength, natural durability, dimensional stability, and beautiful textures. However, main problems are very long harvest cycle and cutting period. Therefore, the demand cannot be met by availability of its stands. Since 2006, Research Center for Biology and Biotechnology, Indonesian Institute of Science, have been promoting and planting fast-growing teak, which is a mixture original introduced clones and uncharacterized mutant induced by gamma-irradiated tissue culture derived from one of the introduced teak genotype. As fast-growing clonal trees, they are expected to have shortened harvesting period with characteristics comparable to conventional teak, especially in strength. Therefore, it is necessary to characterize quantitative analysis of the wood quality to determine the appropriate harvest period and proper use of the wood. Wood samples were taken from teak tree stands with various ages at 3 different growing sites in Cibinong Science Center area, Bogor. The experiment had been conducted from 2015 to 2019. Wood samples were prepared from the bottom, middle, and upper part of the stem of appropriate sizes for different analysis and measurement. Microscopic structure for anatomical observation were follow the International Association of Wood Anatomists. The fiber maceration of wood samples were prepared by using modified Franklin methods. The analysis of chemical components were carried out using the Mokoshisu Kakakujiken manual standard. Physical and mechanical properties measurements were tested according to British standard. This slide shows the anatomical observation of 5-year-old LIPI fast-growing teak wood from Site 2. Macroscopic and microscopic features in cross-section, tangential, and radial of the wood were similar to conventional wood. Growing reeds, boundaries, and the early and late wood cell, hardwood, and softwood were clearly distinguished. The fiber length still increased from pitch to the bark, showing that the wood consists of juvenile wood. Therefore, the wood at the edge has low dimensional stability. Dimensional stability or TR ratio was lower, 2.16, than that of conventional teak wood. The age of tree greatly affected the proportion of mature wood, where the older trees, the more the proportion of mature cell increased. Chemical component analysis of wood based on tree age, regardless of ground location, show that all variables respond linearly with age, even though with the different R-square value. Generally, alcohol benzene soluble extractive substance increased. Lignin content was not significantly affected. Hollow cellulose content decreased due to the decrease in hemicellulose and pectin content, and alpha cellulose didn't change significantly by the age of the tree. Previous results show that the value of MOR and MOE of the 5-year-old of fast-growing teak in Site 2 were nearly the same as 20 to 30 years old conventional teak wood. Furthermore, we compare the result with the 8 to 10 years old which grown in Site 3. We conduct the observation from 2015 to 2017. It seems peculiar that the value of MOR of 8 to 10 years old fast-growing teak wood grown at Site 3 were slightly lower than that of the 5-year-old at Site 2. But their MOE's value were almost the same. Then we observe again the mechanical properties of LIPI fast-growing teak wood in site 2, which have already 9 years old in 2019. Compared to the older trees of 9 years old at the same site, this MOR value increased significantly by 30% in 5 years. MOE value increased significantly by 20%. This table shows the summary of density and mechanical properties of LIPI fast-growing teak wood from 5 to 10 years old. Generally, the density MOR and MOE of 8 to 10 years old of the wood which grown in site 3 were lower than that of 5 and 9 years old which grown in site 2. The density of fast-growing teak at site 2 showed notable increase with age, but was still lower than conventional teak wood. MOR value of 9 years old fast-growing teak was almost 20% higher than that of 60 to 80 years old conventional teak wood. Difference in those values could possibly attribute to genotype of the trees grown on those two sites. The trees on site 2 were composed of 2 selected clones, while the tree composition of the site 3 were unselected mutant, which therefore might have incurred more variability between trees. Compression strength prior to the grain of 9 years old LIPI fast-growing teak wood value were almost double from the value of 5 years old teak trees at the same site. This slide shows the strength class of Indonesian woods according to the Indonesian Forestry Vademecum. All of the 5, 8, 9, and 10 years old fast-growing teak which grow in site 2 and 3 can be classified into strength class 2. In addition, the compressive strength prior to the grain value of 9 years old which grown in site 2 can be classified into strength class 1. As conclusion, anatomical observation of 5 years old fast-growing teak wood show that there were not in a wide variation compared to conventional teak wood, both in their macroscopic and microscopic features. The fiber length of 5 years old in site 2 still increased from pith to the bark, showing that wood consists of juvenile wood. There were changes in chemical component which increased age of the fast-growing teak, especially the extractive substance in alcoholbenzene and hollow cellulose or hemicellulose. Meanwhile, lignin and alpha cellulose level didn't show a huge different change with increasing wood age. This indicates that the two components were not affected by the age of the wood. Density, MOR, and MOE value depend on the growing site, age of the trees, and part of stem. The fast-growing teak woods up to 8 years of age could be categorized as strength class 2. Meanwhile, the 9 years old wood from site 2 could be classified as strength class 1. The fast-growing teak wood has very good prospect to be developed and codified as an alternative raw material for furniture and medium to high quality for timber frame structure of wooden construction. Lastly, I would like to thank to Japan ASEAN Science and Technology Innovation Platform, or JASTI program, which has partly funded to conduct this research for a period of 5 years from 2015 to 2019, and thanks to Japan Society for the Promotion of Science, or JSPS, for publication support as well. Thank you very much for your attention.
Thank you, Professor Wahyu, for the presentation. Ladies and gentlemen, do you have any question? Please raise your hand. We can have 2 questions, 1 question at a time. Anyone? Please raise your hand using a raise hand button. So the presentation is about characteristic of fast-growing thick wood at different age and growing sites.
Maybe if there's no question, there are some co-author here, Mr. Danang and Dr. Rati, and maybe they can add more about the data or give us some comment.
Okay.
Yeah, is it possible?
Yes, please. Please,
Yeah,
Dr. Rati.
sorry, my camera is off because I have another meeting here.
Okay.
Thank you very much, Professor Dwianto. I will not add the data, but just to inform that some characteristic of fast-growing tree is influenced by site and also some affected by genetic. For example, the site effects. You can see there are different sites that used by Professor Dwianto in our research that side effect is more dominant on wood density, wood hardness, and also in the shrinkage. While the MOE, fiber length, and crystallinity, it is from another study, were affected by genetic effect. So, if we want to get the best characters of our fast-growing thick, we can thinking or which will be which will be choose. We choose the density, or we choose the fiber length, for example. So we can sorry, I have to. So we have to think about the effect of this the site or effect of the genetic for the fast-growing thick development. Thank you.
Do you give a recommendation or asking, Dr. Rati?
This recommendation, Prof.
Okay. Yes, I think if we try to observe the fast-growing teak because of their produced from mutant and also clones, and so many clones, mutant and genotype. So we have to be careful on the genotype. For example, for this research result, we a little bit confused about the result because 8 to 10 years old in site 3 is lower than that of 5 years old in site 2. So I think the growing site and genotype have a strong correlation, strong on the density and the strength of the wood. But after now, we still continue the research by non-destructive testing. I mean that we don't have to cut the trees, and we can get the sample by give some take some sample also, not have to cut the trees. Yeah, we still continue to this investigation to get a relationship between density and maybe growing site and also diameter, and maybe we can predict the mechanical properties. That's my comment. Thank you. Thank you, Bu Apriwi. Dr. Amran, do you have any?
Pak Imran, yes, please. question?
Want to ask Professor Wahyu.
Yes, please. One short and simple question, please.
Yes. What is your suggestion to cut the fast-growing tree? What age? What age? I mean.
You mean what age when I cut the tree?
The best time, the best age, according to your research. Thank you.
The precision time to cut the trees, we don't decide it yet, but I think maybe it's about 9 to 10 years old. It's a good time for cutting the trees, because we know that the result we saw the result that the trees has already categorized into strength class 2. Yeah, but we should have more data, I think. Thank you.
Okay, thank you, Professor Wahyu. I'm so sorry for other participants that would like to address the question. We are over time here, so we will speed up the pace a little bit. Now we move to the second presenter, and I hope he is already with us today. Is Mas Hendra from Gajah Mada University. And he's going to present determination of antifungal activity from hydrophilic extract of Swietenia macrophylla kingbark. Now let's hear the video presentation. IT team, please, number 302.
Hello everyone. Thank you for the time and for the opportunity. My name is Mas Hendra, and I am represent for my professor, Professor Ganesh Mandaru. Today, I would like to present our study. It is about determination of antifungal activity from hydrophilic extract of Swietenia macrophylla kingbark. The introduction. In Indonesia, Swietenia macrophylla is used for furniture material. However, the utilization of this species for furniture material discards the bark as residue. We know that the bark is rich in polyphenol, and the polyphenol is potential for antifungal activity. Recently, the use of synthetic preservatives is under questioning. It is due to the environmental conditions. That's why it is needed to explore the natural preservative from the plant, in this case the bark. In this study, the bark of Swietenia macrophylla is separated to inner bark and outer bark. This is due to the difference of inner bark and outer bark characteristics. Therefore, the objective of this study is to investigate the hydrophilic extract of Swietenia macrophylla inner and outer bark, and to determine antifungal activity of hydrophilic extract from Swietenia macrophylla inner and outer bark. Next is the materials and methods. The inner bark and outer bark of Swietenia macrophylla, so it is around 40 mesh powder, was extracted in reflux method with enhexane solvent to obtain enhexane extract and methanol solvent to obtain methanol extract, and water solvent to obtain water extract. In this study, only methanol extracts that were subjected to the antifungal and PCMS analysis. This is the antifungal analysis. So using white rod So briefly, in Petri dish with 20 milliliter of PTA, so this is the Petri dish with 20 milliliter PTA, the methanol soluble extract of Swietenia macrophylla inner and outer bag around 300 microliter. So this is 300 microliter was spreading to the Petri dish with PTA, and then the solvent was dried for 1 hour. And then after drying of solvent, the white rod, in this case Pana Rosaete chrysosporium, was inoculated. So this is around 0.5 multiple 0.5 centimeter of white rod, and then incubation for several days. And this is growth inhibition of sample A1, and growth inhibition of blank or A0 was conducted without extract. And this is how to measure growth inhibition of antifungal activity. A1 divided A0 multiplied by 100, where A1 is growth inhibition of sample and A0 is growth inhibition of blank. In this experiment, the positive control of biocide was used as comparison, and the IC50 value was made with concentration of 500, 1000, and 2000 microgram per milliliter, and each sample was conducted in 3 replications. The next is the CMS simulation method to investigate the hydrophilic compound from the methanol soluble extract of inner and outer bag of Swietenia macrophylla. Briefly, 1 milligram methanol extract was dissolved in 50 microliter pyridine, and then the solution was reacted with 100 microliter BSA and PMCS 99 per 1 volume per volume, and then the sample was heated at 100 degrees Celsius for 30 minutes. After heating, the sample was cooled at room temperature for 20 minutes, and to the sample solution 1 milliliter of methanol was added, and for analysis 1 microliter sample was injected to the machine of GCMS. The next is results and discussion. This is the fungal inhibition of Swietenia macrophylla inner and outer bag. We can see the outer bag showed greater activity, so it is around 1500. Then inner bag is around 2400. So outer bag IC50 was lower than inner bag. It means the outer bag showed greater activity than inner bag. However, compared to the positive control of biocides, the activity of both inner and outer bag was still in low activity. So we can see this is the outer bag sample and this is the inner bag. So outer bag showed the better activity of antifungal than inner bag. It is assumed that the greater activity of Swietenia macrophylla outer bag is due to this layer as protector for inner bag and other living tissues in the trees. The next is the hydrophilic compound. So this is the hydrophilic compound detected in inner and outer bag of Swietenia macrophylla, and this is identified as TMS, 3-methyl silyl derivative. So around 10 compounds were detected in the inner and outer bag of Suetenia macrophylla. In the inner bag, this is the highest compound is myo-inositol. This is a sugar. And in outer bag, also sugar, but mannitol. Myo-inositol and mannitol are non-structural carbohydrate. This carbohydrate is used for growth of the trees. Besides sugar, there is another compound, in this case a polyphenolic compound, such as pyrrocatechol, catechin, and epicatechin. In this study, the polyphenolic compound or phenolic only detected in the outer bag. However, the presence of phenolics in the inner bag is limited or very low. The dominant sugars in the inner bag indicated that this layer rule in transporting or storing the sugar. But the presence of sugars in outer bag, it is still under question. However, the presence of phenolics such as pyrrocatechol, catechin, and epicatechin in the outer bag, it is indicated that this layer is protecting the inner and living tissues of the trees. The next is the correlation of antifungal and related compounds. The higher antifungal inhibition of outer bag than inner bag was supported by the presence of phenolics such as catechin, epicatechin, and pyrrocatechol. The presence of phenolics compounds, namely lignan in species of Pinus mercusii wood and latifolin in species of Dalbergia latifolia wood, was reported to have antifungal activity. So, the phenolics in the outer bag was responsible to inhibit the fungal activity. The next is the conclusion. The antifungal activity level in outer bag was higher than that inner bag. The higher level of antifungal in outer bag finding was suggested by the presence of polyphenolic compounds in the outer bag, such as pyrrocatechol, catechin, and epicatechin. The presence of concentrated sugar compounds rather than polyphenolics in both inner and outer bag of Suetenia macrophylla gave under mild activity of antifungal for two samples. And the last is the polyphenolic compounds from Suetenia macrophylla outer bag is potent for natural preservative material. Thank you.
Okay, thank you for Pak Masendra. The video presentation is about fungal activity, antifungal activity from the plant extraction. Do you have any question here, ladies and gentlemen? Okay, Pak Masendra, if I just want to clarify, why you only included the methanol extracted antifungal in the bioassay? So if I'm not mistaken, there were three methanol and the other two, but you only use the methanol extract for the bioassay.
Well, thank you to Aprili. Can
Yes.
you hear my voice?
Yes, quite clear. Please.
Actually, we already done the experiment for antifungal of 10 hexane, but not in the hot water extract. In the study, we just try to investigate the hydrophilic extract. You know that 10 hexane may dissolve some lipophilic. Due to the title is hydrophilic, so we didn't show the data of N-hexane soluble extract of the antifungal activity. Maybe in the next presentation or in the next seminar, we'll try to inform the data of the N-hexane soluble extract from the inner and outer part of mahoni or Swietenia macrophylla. Thank you.
Okay, thank you. We can have one more question, audience. Is there anyone want to ask?
Next question.
Oh, okay. Okay. Which one?
Okay.
Okay. Widya, please. Widya, please.
Okay, thank you, Mrs. Abriwi. I just want to know what is why you choose Padero head Chrysosporium compared with the other white rot fungi in this your antifungal analysis, and then what is the difference between three what's active, pyrocatechol, catechin, and also epicatechin in the antifungal that in your antifungal data? What is the difference role between three components? Okay, that's all.
Thank you. Is it direct to answer or the next?
Yes, please. Yes, just directly answer the question.
Okay, why I chose Panerocytic Chrysosporium white rot? In laboratory we have this one, and actually we try to try one from IPB University, but you know that versicolor, Trametes versicolor, maybe it is brown. Would like to try one that the ability of the Trametes versicolor is not good in our laboratory. Only this species, Panerocytic Chrysosporium. That is the first question. And the second one is the difference in the working of catechol, pyrocatechol, and catechin. Maybe catechin and epicatechin and pericatechol, they have a hydroxyl structure in layering, in bearing of bearing of catechin and epicatechin. But the important point is the hydroxyl structure in the ring of catechin and epicatechin, or also pyrocatechol. The hydrophobicity of the catechol structure in the inhibit of white rot is very important to explain why phenolic is good for inhibiting the white rot activity. However, we still do not understand how catechol or pyrocatechol with catechin. Catechol is a monophenolic, but but catechin and epicatechin is a polyphenolic, so the phenol is more than one. Is that answer the question to here?
Okay, thank you.
This is due to the catechol structure, hydroxyl structure in the catechol. Actually, maybe pyrocatechol is better than catechin and epicatechin, but we didn't try to isolate the pyrocatechol first compound and the second compound and the third compound for each fungal activity. Maybe for the next research, it is needed to isolate the pyrocatechol and another phenolic compound, and then subject it to the antifungal activity.
Yes, I think so.
Okay, thank you, Bu Widya and Pak Mas Hendra. Now we will move to the third presenter. Hopefully he is here with us. It's from Muhammad Rashidur Ridho from Research Center for Biomaterials BRIN. He graduated from the Faculty of Agriculture, University of Jambi, and this year he has published 2 international and national journal with 3 registered patent and 1 copyright. and his research interests on natural fiber anatomy and lignin utilization. At the moment, he's pursuing a master degree program in IPB University. Okay, IT team, please video number 303.
Thank you for the opportunity. I want to present our paper entitled The Effect of Harvesting Time on the Fiber Qualities of Knaf and Roselle. So introduction, Knaf and Roselle are annual plants that mature in 3 until 5 months for Knaf and 7 until 8 months for Roselle and generate 1.5 until 3.0 tons of fiber per hectare. Sujindro 2011 and Karim et al. 2021. According to Romeo 2019, global Knaf production data production decreased by 19% between 2012, 2013, and 2018, 2019. Understanding fundamental aspects of natural fiber, such as their morphological characteristics, is vital for choosing the optimal application, such as high-quality biocomposite raw material. The benefits of Knaf and Roselle fiber include reinforced polymer composite, as well automobile parts and accessories, as a starting material for manufacturing currency paper, the nautical, agricultural, and shipping industrial as a rope and yarn. Fiber dimension size according to Samsudin and van der Vossen 2003 for Knaf fiber are 1.5 until 12 mm in length, 7 until 41 micrometer in diameter, 7 until 13 micrometer in lumen width, and 4 until 9 micrometer in cell wall thickness. And whereas Roselle fiber are 1.2 until 6.3 mm in length, 10 until 44 micrometer in diameter, 3 until 15 micrometer in lumen width, and 4 until 15 micrometer in cell wall thickness. According to Sakhes et al. 2012 and Folgaridis et al. 2002, plant type, age, harvest period, and axial position on the plant stem influence the fiber size in plant. So the purpose of this study is to ascertain the difference in fiber diameter in the axial position of Knaf and Roselle fiber due to harvesting time difference. It focuses on the analysis of fiber diameters and fiber different value derivatives. Knaf and Roselle samples were taken from the Indonesian Sweetener and Fiber Crops Research Institute Malang, Indonesia. The Roselle and Knaf sample were taken before the harvesting 3 and 5 months respectively, and the harvest time 4 and 7 months respectively. Knaf and Roselle sample were measured by adding hydrogen peroxide and acetic acid glacial and boiled with a water bath or hot plate. The sample were washed with distilled water 4 until 5 times and add with saffron solution. The fiber were then observed using a microscope Olympus PX163 equipped with a digital DP73 camera, obtained fiber image with 4 and 10 times magnification. The dimension of the image were measured, namely fiber length, fiber diameter, lumen cell, and cell wall thickness, using ImageG software. From the measurement result, the fiber derivative value was calculated. Result and discussion. The following data show the measurement result of Knaf and Roselle fiber dimension, showing the sample code RC2 has the highest total score of 35. The fiber dimension of Knaf, fiber length, fiber diameter, lumen cell, and cell wall thickness are greater during harvesting time than before harvesting time. while in Rossel, fiber length and cell wall thickness were greater during harvesting time than before harvesting time. And yet, fiber diameter and lumen cell were higher before harvesting time. On the stem, base, middle, and top, each part has a difference in size. The measurement result of fiber knaf and Rossel at 3 stem positions. Knaf and Rossel plant obtained fiber length increased from the base to the end of the stem, except at knaf at harvesting time, where the fiber length increased from the two base. The following table shows the result of the calculate of the fiber derivative value of knaf and Rossel. It can be seen in the sample code RA at before harvesting time gets the highest total score 50. Wrinkle ratio. According to Ververis et al. 2004, the higher wrinkle ratio fiber are stiffer, less flexible, and from bulkier paper with lower bonded areas. The wrinkle ratio is not related to the harvesting season, as the maximum value of knaf is before harvesting time. In contrast, the highest wrinkle ratio value of Rossel is found during harvesting time. Felting power. The fiber becomes more flexible as the felting power increases, while the fiber becomes stiffer as the felting power decreases. Aprianis and Rahmayanti 2008. The knaf has the highest felting power at the top stem, sample code KE2C, implying that the highest fiber length is also at sample code KE2C. On the other hand, Rossella has the lowest felting power at the middle stem, sample code RB. Consequently, the short fiber length is also at sample code RB. Next, flexibility ratio. The value of the highest flexibility ratio in the Rossel plant was in the middle stem position before harvesting, while the knaf in the base stem before harvest had the smallest value. High flexibility fiber has a thin cell wall thickness and is easy to form. This formability makes contact between the fiber surface more flexible, resulting in greater fiber bonding and stronger pulp sheet if utilizing in paper marking. Coefficient of rigidity. According to Istiqowati et al. 2016, thin cell wall and a large lumen diameter are linked to a high stiffness coefficient. The Rossel in the middle stem, sample called RB, had the lowest cell wall value and maximum lumen diameter value. In the study, the coefficient of rigidity has the lowest value obtained by Rossel on the middle stem, sample code RB. This fiber allows it to be used as a pulp raw material. According to Fatriani and Banjarbaru 2070, it must have a low coefficient of rigidity in the pulping process. Mole step ratio. The mole step ratio value for class 2R 60.310 and 50.785 respectively, with a proportion of 60 until 80% of Rossel species attained before harvesting time on the base and middle stem. Knaf species were acquired both before and during harvesting time in complete stock for class 3, which had a percentage of up to 18%. The lower the mole step ratio, the higher the strength and density of the pulp sheet, and vice versa. Aprianis and Rahmayanti 2008. This table summary of the assessment of the fiber dimension and fiber derived value of Knauf and Rossel fiber. Sample code RB, Rossel in middle position of steam before harvesting time, has the highest score value. Sample code RB is the most suitable as raw material of pulp and paper. While in harvesting time, sample code RC2, Rossel in top position of steam after harvesting, more recommended as raw material for pulp and paper. So the conclusion, first, the fiber diameter dimension of fiber will increase as harvesting time increase. Except for Knauf in the harvesting period, fiber length grow from the base to the top. Second, the difference in harvesting time in Knauf and Rossel plant did not affect the fiber derivative value and the three axial positions that got different values in each part. Third, Rossel plant before harvest time and harvest time are more recommended as pulp and paper raw material compared to Knauf plants. And fourth, the appropriate steam position as pulp and the paper raw material on in the middle position of the steam before harvest time and position on the steam at harvest time. Thank you.
Okay, thank you for the interesting talk, Pak Rashid. Ladies and gentlemen, we only have one question for this presentation, and Pak Adli, please ask your question directly.
Thank you very much for presentation, Mr. Rashid. I just want to ask a simple question. What is the proper harvesting time for Knauf and Rossel based on your study, and why? Thank you.
Rashid, are you there? Maybe other co-author present to this session can answer the question from Pak Adli. What is the best time to harvest the Rossel and Knauf based on the study, and why?
Miss Apriwi.
Okay, please,
Okay, maybe can you so the last one, the last slide, I mean, in the last slide, you can see that in for the Rossel and Knauf is a different behavior in the characteristic of the fiber, such as for the Knauf in we want to know how the fiber characteristic in the top, in the bottom, and also in the middle. And for the research, we can see that in the middle part of the Rossel, yes, it is a better characteristic compared with the other part. So in this observation, we can yes predict that if we harvest the Knauf in before the harvesting time for in particularly for pulp and paper is will better characteristic compare with the other, but in Rossel not give this similar characteristic with the Rossel. I think it's my comments. Maybe I just want to share that this study is a small part of our project in how we just develop the informatic system of natural fiber, and in this namely lensa, and maybe we will open on the next for all users. I mean, to know how the characteristic of the some maybe almost 100 samples of the various kind of the fiber. Thank you.
Okay, thank you, Bu Widya. Now, audience, we'll move to the fourth presenter. It is from Hana Gultom from University of North Sumatra. She has obtained the bachelor degree from the Faculty of Forestry, University of North Sumatra in 2021, and she's interested in the world of plant cultivation. So during her studies, she majored in forest cultivation. She also has a hobby of exercising, especially jogging, and for Hana, plants and health are important and interrelated with each other. So IT team, please play video number 304.
I will explain the research under the response of reservoir Berdaulat, through the application of various types of fertilizer in Berdaulat village, Pangkalan Barat, Sumatera, by Winaspi, Hana Gultom, and Muhammad Bashir. Introduction. The condition of the mangrove forest area is currently quite alarming. It is known that the area of mangrove forest is decreasing with the change from mangrove forest to an industrial area. Given that mangrove forests have many roles and functions that are very important for living things, it is necessary to maintain the preservation of mangrove forest vegetation, one of which is planting and applying fertilizer to the type of mangrove plant, namely Rhizopara peculata. The characteristic of the soil in marine mangrove forests, which are always wet, humid, and fair condition, and mangrove plants that are affected by tides, make the process of inserting fertilizer into the soil quite difficult. And the soil in this mangrove forest is rich in organic matter. The purpose of this study was to determine and analyze whether there was an effect on the growth of Rhizopara peculata seedlings given NPK fertilizer, chicken fertilizer, cow fertilizer, quail fertilizer, or not. Methodology. Time October 2020 to May 2021. Study site Mangrove Forest, Berdaulat Village, Barat District, Langkat Regency. Forest Cultivation Laboratory, Faculty of Forestry, University of North Sumatra. Materials: Rhizopara peculata seeds, NPK fertilizer, chicken fertilizer, cow fertilizer, and quail fertilizer. Main text: plastic rope, sample envelopes, millimeter paper. Tools: analytical balance, ruler, caliper, stationery, oven, camera, laptop, SPSS application, and calculator. Research procedure. This research is an experimental method using a completely randomized design consisting of 5 treatments and 4 applications. Each application consisted of 1 plant, so there were 20 experimental units. As follows: P0, the fertilizer application, P1, NPK fertilizer, 12 gram, P2, chicken fertilizer, 100 gram, P3, cow fertilizer, 200 gram, P4, quail fertilizer, 5 gram. Research procedure: 1. Land preparation, 2. Planting, 3. Fertilizer application, 4. Maintenance of Rhizopara peculata seedlings, and 5. Harvesting. Observation and data collection. Research parameter: 1. Seedling height, 2. Seedling diameter, 3. Number of leaves, 4. Temperature, 5. Weight of the plant, 6. Plant dry weight, 7. Leaf area, 8. Leaf area index analysis. 9. Plant growth rate. 10. Data analysis. Result, seedling height. In the seed height variable, the result of a significant value in table 1 are 0,178, which means that it is greater than 0.05. So the result has a significant effect, and there is no need for MRT or Denver testing. 0.05 is a number to determine whether the test is necessary or not. If the significant value is greater than 0.05, then the result is said to have no significant effect. If it is smaller than 0.05, then the result has a significant effect. 2. Seedling diameter. In the seed diameter variable, the result of a significant value in the table is 0,476, which means it is greater than 0.05. So the result of its treatment has no significant effect. In the future, the MRT test is needed. And in table 4, treatment P1 gets the largest average value compared to the other treatment. 3. Number of leaves. In the variable number of leaves, the result of a significant value in the table is 0, which means it is smaller than 0.05. So the result between treatments have a significant effect, and further, the MRT testing needs to be carried out. And in table 6, treatment P4 gets the largest average value compared to the other treatment. Because the result have a significant effect, it is necessary to carry out further the MRT testing. And on the slide are the results of the MRT follow-up test. For plant wet weight and plant dry weight. Figure 1 presents that the highest wet weight on the stems of Rhizopora apiculatus seedlings was at P0 or control not given fertilizer of 30,649 grams. The wet weight on the stems of Rhizopora apiculatus seedlings was the lowest at the application of P2 or chicken fertilizer 100 grams of 25,709 grams. Then the highest wet weight at the roots of Rhizopora apiculatus seedling was given P4 quail fertilizer 5 grams of 11,696. The lowest weight at the root of Rhizopora apiculatus seedling was given P1 or NPK fertilizer 12 grams of 6,436, and the highest weight on the leaves of Rhizopora apiculatus seedlings was given P3 or cow fertilizer 200 grams of 6,402 grams. Weight on leaves of Rhizopora apiculatus seedlings, the lowest was on P1 or NPK fertilizer 12 grams point of 1,802 grams. Because the result have a significant effect, it is necessary to carry out further DMRT testing, and on the slide are the results of the DMRT follow-up test. 5. Leaf area. In the leaf area variable, the result of the significant value in the table are 0, 0, 2, 1, which means it is smaller than 0.05. So the result between treatments have a significant effect and further DMRT. testing needs to be carried out. And in table 9, the P3 treatment got the largest average value compared to the other treatment. Because the results have a significant effect, it is necessary to carry out further DMRT testing, and on the slide are the results of the DMRT follow-up test. 6. Leaf Area Index Analysis. In the leaf area index analysis variable, it was found that the significant value in the table was 0 or 2, 1, which means it was smaller than 0 or 5. So the result between treatment had a significant effect and further DMRT testing was needed. And in table 11, the P3 treatment got the largest average value compared to the other treatment. Because the results have a significant effect, it is necessary to carry out further DMRT testing, and on the slide are the results of the DMRT follow-up. Plant growth rate. Based on the growth that observed in Rhizopora picculata seedlings given the treatment, the highest seed height increase was in the treatment of P3, and the highest seed diameter parameter was in the profession of P3, and the P3 treatment was able to increase the increase in stem diameter of Rhizopora picculata seedlings by 1-2 cm for 12 weeks. In the parameter of the number of leaves, which had the highest number, the administration of P4 was able to increase the number of leaves by 15 strands for 12 weeks based on the calculation of the growth rate of Rhizopora picculata seedlings with P1. The lowest value was 11-2 for 12 weeks. Seedlings was given P3 with the highest data values on 3 variables from 6 variables, namely the weight variable and the leaves with a value of 6,402 grams dry weight and leaves with a value of 1,797 grams and leaf area with a data value 79.1 and average of 98. Giving P3 also affected the analysis of leaf area index and growth rate on the height and diameter of Rhizopora picculata seedlings. It is better to do further research by giving a larger dose of organic fertilizer. Thank you.
Okay, thank you for Miss Hannah for the presentation. Now, ladies and gentlemen, is there anyone want to raise their hand to deliver a question for Miss Hannah presentation? We can only have one question, unfortunately, due to the time limitation. No one? Okay, I'll try to ask a question. Is there Miss Hannah? Is Miss Hannah presents in this session, or is there a co-author this session? I saw Ibu or Bapak Yunasvi 304 here. Okay, hello.
Yes.
Okay, Ibu Yunasvi, can you hear my voice? Is my voice clear?
I can hear.
Okay, thank you. Thank you for the presentation by Miss Hannah. So I'd like to just short question. The plant was treated by several fertilizer, namely organic fertilizer from animal such as cow, quail, and chicken. I just like are they were they a commercial fertilizer, or your team has make special treatment to the fertilizer, to this experiment? Are they just readily to buy fertilizer, or just special, or you take it special for the farm, or etc.? Please, Ms. Yunaswi.
Hello.
Yes, hello, please. Did you get my question?
Please once again, Miss.
Okay, so the treatment used in the research were cow fertilizer, quail fertilizer, and chicken fertilizer. Were they readily available commercial one, or you and your team actually get it from the farm, or how? Thank you.
So for the fertilizer, I buy this fertilizer from the farm.
Okay, so you buy from the farm itself, not the commercial in the plant shop, or something like that.
No, I buy from the farm.
Oh, okay. Okay, so anyone, I offer one time once more for the audience. Is there any question? Okay, Pak Gunawan Pasaribu, just one short question, please, directly.
Okay, thank you. Is my voice clear?
Yes, okay. Very well. Thank you.
Thank you. I want to know about do you analyze the difference of macro or micronutrient in each fertilizer? Because it is important to how to know the difference in each fertilizer. That's all. Thank you.
Sorry, Mister. Your voice is very small.
Oh, okay. Do you analyze about the fertilizer you use in the research, differences in micro or macronutrient in each fertilizer, like from coal, from the other fertilizer?
Yunaswi, did you get the question?
It is important how to compare the fertilizer one to the other fertilizer.
Yeah, I'm so sorry, very small, Mr.
Oh,
Gunawan.
okay. Maybe in chat room, okay.
Okay, I will repeat one time. So, did you analyze the macro and micronutrient from each fertilizer in your study? Is that how is that your question, Pak Gunawan?
Yes, it's right.
Please once again.
Okay, did you analyze the difference of macro and micronutrient contained in each fertilizer that you use in the research?
Oh, I don't analyze difference or macro. Oh. Hello.
Yeah, please. Just please directly answer the question, Bu Yunaswi. Oh, probably there's something trouble with the connection.
Thank you.
Okay, thank you, ladies and gentlemen. We actually over time here, and we will have a break, lunch break. Actually, it's for 1 hour, but we only have 40 minutes lunch break, and we will be back in this room in 1:30 sharply. We will start sharply. Please use this. Break for lunch or for pray, or just sometimes online meeting can be so exhausted. So thank you. I will see you in 1:30. Wassalamualaikum warahmatullahi wabarakatuh.
Recording in progress.
Okay, so good afternoon, everyone, and once again, welcome. Okay, so as we just announced in the chat room that we just currently have technical issues with the breakout room. So please, right now, we are ready to open again the breakout rooms as
Recording in progress.
Display the video number 305.
Yeah, but unfortunately, this video start now. Yeah.
On Exploring of Natural Agarwood, a case study of Papua, Indonesia, by Herman Hidayat, Indonesian Institute of Sciences, or LIPI, the Research Center for Society and Culture, 2021. Definition and its characteristic. Definition. Agarwood or kayu gaharu. Agarwood is an aromatic substance in the form of light brown to black lamb that are found between wood shell and of several tree species. Its characteristic. It is non-timber forest product or NTFP. It is domestic and global commodity. It is high economic value due to its price. It is used for material burning in religious event, lifestyle product, perfume, medicinal purpose, decoration, etc. It is categorized in CITES rule to determine quota for trader due to limited production in natural forest. It is used necklet, key holder, bracelet, etc. to prevent from devil trouble. This is, I show the picture. Agarwood material is an aromatic substance. This agarwood type of super king. This price almost $5,000 to $6,000, very expensive. And this is the cultivation agarwood of Aqualaria malacensis. And this tree, the third picture, the agarwood tree injection by liquid to obtain guba or essential material of the good smell. It is the white 2 years production of the guba. Agarwood and its development. In Indonesia, agarwood has been known since 1200, which is clearly shown on the trading list of barter material among people. In 1600, agarwood used in exchange trading material among traders, for instance, Indonesian with China, Dutch, and Portuguese, Arabia, etc. In 1960 up to 1980s, agarwood mainly produced in India, Bangladesh, Vietnam, Thailand, Laos, etc. In 1990s, Indonesia, or 70%, and Malaysia, or 30%, emerged as the main supplier for agarwood. Foreign exchange earnings from agarwood revenue reached $1.7 billion in 2017 and decreased to become $1.3 billion in 2018. Aqualaria malacensis and Microcorpha are found in Sumatra and Kalimantan. Aqualaria filaria and Greenops Podocarpus are found in Maluku and Papua. Greenops frestigi are found in West Java and Nusa Tenggara Barat province. This is the picture I show you. This is the table I show you. Agarwood importing countries have specific choice of product. For example, area or country, Arab society, type of agarwood such as Aqualaria malacensis, material used for ingredient for perfume, religious tradition. And Indian society, for Aqualaria malacensis, it is used for ingredient for perfume, registration. For Chinese people, Aqualaria sinensis, it is used for medicinal purposes. For South Korean society, Aqualaria malaysiensis, ingredient for perfume and used also for religious tradition. For Japanese society, Aqualaria krasna, it is used for meditation. This figure about the target of quota for agarwood breeder don't reach to the shortage production. For example, in 2016, the volume of the agarwood reached about 128,250,000 rupiah, but really decreased in 2016, for example. Just find the taxes revenue about 42,500,000, and really decreased in 2018 just 27,900,000. This table about estimation of export value in million of Indonesian agarwood from importing countries in 2018. For example, country export volume per kilo and export volume per kilogram. This is Singapore, reached about 9.6 million in US dollar, but export volume per kilo about 137,5 to 3 kilo. Arab Saudi about 27.16 million, but export volume just 808.910 kilo. And Uni Emirat Arab export volume reached about 15 million, 0.47 US dollar. But the export volume per kilo just 221.502 per kilo. Taiwan about 1.85 volume US dollar. But the volume, export volume, 106.893 kilo. China, about 1,000,000.4, but the export volume about 315.774. South Korea, export volume US dollar 105 million. This is, I would like to show you about the framework of the methodology. Discussion about theoretical view, we discuss about stakeholder role from the government, the role of the government, for example, the KITA office, a board of the Natural Resource Management Office, local government atau forest agency in province level, or local people, seeker of the natural agarwood, a trader of agarwood district, a trader of agarwood in province, or Pegatri, Asosiasi Gaharu Indonesia. And this is the natural agarwood exploration. So this arrow come here, natural agarwood, and this is mutual. The factor of decreasing natural agarwood product. First, regarding overexploitation. A production forest converts into estate plantation or logging forest concession or industrial timber plantation or transmigration or mining sector. And the method of this research based on the library research, interview with informant, participation observation, and forum group discussion or FGD. Natural agarwood known by Papua people. In 1990s, Papua people knew that natural agarwood is commodity and has its economic value. A trader from Japanese, Sumatra, and Bugis initially introduced natural agarwood as commodity to Papua people. In seeking natural agarwood found 4.3 trees per hectare. In 1995 up to 1000, trader got permit related to agarwood process to be collected from Presti Agency in province level and from the KSTE or Natural Resources Agency office to find that quota. In early 2000, natural agarwood is to be prima donna commodity with high selling price and barter from foodstuff among Papua people and local bureaucrats, military, apparatus, actively participate how they meet the business of agarwood. Natural agarwood were found in 28 districts spread in Papua. This is the table, the spread of natural agarwood in 28 districts in Papua. If you see province, the spread of district and amount. For example, in Papua province, you can see Asmat district, Mepi, Mimika, Merauke, Nabire, Puncak Jaya, Torikara, Pegunungan Bintang, Yakuhimo, Waropen, Yapen, Biak, Membrango Raya, Membrango Tengah, and Kerum, altogether about 20 districts. But in West Papua, it is less, just 8 districts. For example, in Fakfak, in Kaimana, Teluk Wondama, Teluk Bintuni, Manokwari, Sorong Selatan, Sorong District, and Raja Ampat District. A profile of agarwood trader in Papua. Junaidi was born in Payakumbuh, West Sumatra, in September 1966. He started business of natural agarwood in 1904 in Papua. He established a Papua Intan Lestari company in 1996, which is based in Santani City, Jayapura district. The operation of this company covers in Merauke, Mapi, Asmat, Membrango Raya, Intan Jaya, Yapen, and Waropen district, etc. The company employs 5 up to 6% of seekers and a prior pay about 10 up to 12 million to search natural agarwood. If seeker got agarwood in super and Kamadangan grit, they give to trader or Junaidi according to the spot price. A trader company from Jayapura has good relation with big trader in Jakarta and got huge capital, reach from 500 million rupiah up to 1 billion as a client to send natural agarwood with high quality, super king or super level till Kemadangan to trader in Jakarta. This is the figure, natural agarwood trade flow and capital in Papua province. Natural agarwood with 1 scam, this is agarwood seeker 1, plasma or collector 1, this is local businessman in the province, and after that sent to the export into Jakarta. And this is the second scam about the agarwood seeker 2, the plasma 2 or collector 2, sent to the local businessman 2 in province level, and they sent to exported to Jakarta after to overseas. This is, I show you the table about the use of standing agarwood stem in Papua province in 2010 up to 2019. If we see in year 2010, the quota amount about 400,000 kilo, but the quota realization about 359,335 kilo, and the percentage about 49.43. But if you compare with 2017, it is really increased little, about 403,300 kilo. But quota realization about same 403.300, it is same, and it is 100%. But in 2019, for example, this is the quota amount about 473.910, but the quota realization, it is really decreased about 120,000.005, and then really decreased. So if we totally calculate the total, a quota amount about 4.2 million, for example, but the quota realization about 2.5 million. So this is percentage really decreased. This is also the table about the non-tax value income or PNBP, pajak nilai pertambahan di Provinsi Papua, in province of the Papua 2015 up to 2018. If you see, for example, in Asmat district, it is the PNBP received about 1.4 billion, but in 2016 about 970 million, and 2017 it is increased about 1.2 billion dollar, 1.2 billion rupiah, and in 2018 about 1.3 billion rupiah. This is for example, and another district just zero, Yakuhimo, for example, Kiron, just zero. In 2000 just 1.200 million. But in Pegunungan Bintang also zero, and this is on 2018, but 600,000. And then the total PNBP received by the province of the Papua in 2018, it is about 1.8 billion. So if you compare with the 2015, it is received 2015 about 2.1 billion rupiah, but really decreased in 2018 about 1.8 billion rupiah. So we reach about conclusion. Agarwood is non-timber forest project, which is domestic and a global commodity, because economically it has high selling price compared to other non-timber forest production. Indonesia became supplier of agarwood product in late of the 1990s and the early 2000s. Agarwood producer can be found in various provinces in Indonesia, including Sumatera, Kalimantan, Java, West Nusa Tenggara, Sulawesi, Maluku, and Papua. Agarwood product and their trade provide great economic, social, cultural benefit, not only to local communities as natural agarwood producer and seeker, but also Indonesian people from various tribes looking for agarwood to collectors at sub-district level, district level trader, province, and big trader in Jakarta and Surabaya. The largest export of agarwood in international trade include the Middle East, Singapore, Taiwan, South Korea, and China or Hong Kong. Indonesia got foreign exchange earning from agarwood export reached 28 billion rupiah in 2007, for example. In the case of the natural agarwood from Papua province, there are two types of agarwood obtained. First, natural agarwood is obtained from standing agarwood producing trees, and natural agarwood that are obtained from agarwood producing trees that are buried in mud, among others in Merauke, Asmat, Bovendigul, and Mepi district. Second, agarwood cultivation from farmers, but it is not production yet. Although natural agarwood obtained from the mud is not taken into account in international trade, this commodity country contributes significantly to PNBP return to the region in the form of the provision of natural resources for the commodity producing district and provided alternative income generating for the local people who seek it. Agarwood for the Papuan people was introduced by immigrants, especially agarwood traders from Sumatra, Sulawesi, and West Nusa Tenggara, who deliberately came to the Papua to look for agarwood in the middle of the 1990s. Before the arrival of the seeker and trader of agarwood, the Papuan people were not familiar with the trees that produce agarwood, including its use as non-timber forest production. Recommendation: the central and province government as well should perform moratorium to give estate plantation or oil farm or food estate area, logging forest concession, industrial timber plantation, mining, etc., due to the strengthening of the natural forest in Papua, where agarwood plantation rapidly decreasing. The second, the province government, especially Bapeda, Province Planning and Development Board, and Forestry Agency, or BKSDE, Office to do synergy cooperation with local farmers to perform agarwood plantation in respective district due to the economic benefit income, generating and absorb job opportunities for local people. Thank you for your listening.
Thank you, Professor Henry Hidayat, for the thorough presentation. Ladies and gentlemen, we only have time for one question, one short question before we move on to the next presenter, please. Anyone?
Bu Awi. I have one question for Professor Herman.
Please.
Professor Herman, I have one question about the quota amount from the government. Is there any different quota for agar wood grade to sell in the market?
Excuse me, I don't listen. Quota
from the government. Is it any different quota for agar wood grade, or it is just all grade and then government give a quota for the seller?
Yeah, actually the quota just given to the big trader, every province, and then BKSDA office give the quota to the big traders of agar wood, and they have and they should manage, and they should pay a prior to the trading. They have pay first to the government, to BKSDA office. But while I interview to the traders, it is not fair, because the quota sometimes is very high, but the realization is very decreased because the shortage of agar wood in natural forest. We have to pay more, katanya. Then we have to receive from the seeker, from the seeker of agar wood, yeah, in a district, in village, in sub-district. So now decreasing, unfortunately.
Okay, thank you very much.
Okay, now, ladies and gentlemen, we will move on to the second presenter. It is from Azra Zahra Nadira Ikhwan from Research Center for Biology. And she is a researcher in interest in environmental issue and the ecology of microorganisms. Her master thesis was examines the potential of bacteria for microbial enhanced oil recovery. And now she works in the field of microbiology, Research Center for Microbiology, Research Center for Biology Brain. So IT team, please play video number 306.
Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Azra Zahra Nadira Ikhwani from the National Research and Innovation Agency, BRIN, which formerly I was from the Indonesian Institute of Sciences, LIPI. On this conference, I, representing my college, will present our study entitled Response of Fertilizer Type and Urea Dosage Application to Support Sorghum Growth in Ultisols. Indonesia has long been known as an agricultural country with a land area of 1.9 million kilometers squares. However, 78.2% of the total land area is known as suboptimal or marginal land, which is dominated by dry land of 77.2%. This dry land is predominantly acidic, and the largest soil type belongs to the order Ultisols. This marginal land can still be optimized for agriculture with a potential area of 68.98%. Agricultural crops that have the potential to be cultivated on Ultisols are sorghum, which is known to be drought tolerant. Besides being expected to be a source of food for humans that can help maintain food security as an alternative to rice, especially in Indonesia, it can also be used as animal feed and bioenergy. Suboptimal land use for agriculture is certainly expected to support the SDGs program, especially number 1, no poverty, 2, zero hunger, and 13, climate action. Therefore, soil treatment is needed for suboptimal lands such as ULT soils which tend to lack nutrients for plant growth. For that, a fertilizer treatment can be carried out. In our research, we studied the fertilization treatment of ULT soils as a growing medium for sorghum. We use two factors, type of fertilizers and dose of urea. Each factor has 5 levels, including negative control PO and UO. The treatments applied to the type of fertilizers factor were compost P1, compost added with beneficial microbes inoculants, we call it plus compost P2, slow release fertilizer SRF P3, and the combination of those three P4. The doses of urea used were 25% U1, 50% U2, 75% U3, and 100% U4. The response observed after 8 weeks of planting were based on agronomic characteristics and soil analysis. In agronomic characteristic, combination fertilizer treatment P4 showed the highest value in plant height and number of leaves. Meanwhile, in the urea dose treatment, there was no significant difference in all doses given on plant height. As for the number of leaves, the highest value was on by the 100% urea dose, but it was not significantly different from the control UO. Another agronomic response that was measured was plant biomass. For stock biomass, there is a significant difference compared to control PO, which is the lowest value, while the highest weight is shown in P4. The urea dose treatment showed a significant difference in the highest value obtained at a dose of 25% U1, while the other doses were not significantly different from the control UO, where the lowest value was a dose of 50% U2. The treatment of the type of fertilizer on the response to root weight was also the same as the yield on the stock weight. The highest value was obtained by the combination treatment P4. Meanwhile, the urea dose treatment didn't show a significant difference in all treatments, including the UO control. We move to soil analysis. Soil microbial respiration showed the highest value in compost treatment P1 and 75% urea U3. That was not significantly different from the control PO and UO. Meanwhile, the lowest value is owned by slow release fertilizer P3 and urea dose of 25% U1. For bacterial and fungal populations, the highest value for type of fertilizers was in the combination treatment P4, as in agronomic characteristic mentioned earlier, while the dose of urea, which was sufficient to increase the microbial carbon microbial biomass reflects the level of organic C in the soil and shows the amount of substrate available for plant growth. Addition of fertilizer types had significant effect on C microbial biomass, while the addition of urea dose didn't have a significant effect. The result of this C microbial biomass is similar to the C organic of the soil. The negative control PO has the lowest C microbial biomass and C organic, while the treatment P2 and P4 is the highest. The negative control UO had the lowest of those C, whereas the treatment of U2, urea dose 50%, has the highest C in microbial biomass, and 25% in soil organicity. The addition of fertilizer types had significant effect on soil pH compared to the negative control, while the addition of iodosis didn't have a significant effect. The negative control PO has the lowest soil pH, while the treatment P2 plus compost has the highest soil pH. The effect of compost as an addition to organic matter on soil pH can increase it. The treatment of iodosis didn't have a significant effect on soil pH. The treatment of U4 100% urea has the lowest soil pH, while treatment UO negative control has the highest soil pH. It can be stated that organic fertilizers can improve soil fertility compared to inorganic fertilizers. For the conclusion, the agronomic observation showed the highest values which were significantly different in the combination P4 treatment, and this treatment also gave significant results on the total population of soil bacteria and fungi, and can increase the carbon organic content, while the urea dose treatment didn't give significant result generally, which also there is no positive interaction with the type of fertilizer treatment. And the last, increased production of sorghum biomass with higher soil fertility yield results was achieved when biofertilizers like compost and inoculants with a small amount of synthetic fertilizers as in SRF or urea were applied. That's the end of my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. So thank you for the presentation, Ms. Azra. Now, do you have any question here for the presentation? Anyone? Please use the raise hand button if you like to address a question to Ms. Azra. Okay, Ms. Azra, you said that in your design you use slow release fertilizer. Is that a synthetic one or biofertilizer?
It's a synthetic one that we purchase it.
Okay.
But yeah.
So do the application is follow the product suggestion?
Yes.
Okay. So I return to the floor. Anyone? Is there a more question? We can still have one more question for Ms. Zahra. Azra, sorry. Azra Zahra. Okay. Okay. If so, we will move to the third presenter. It is from Niken Pujirahayu from Halu Oleo University. Ibu Niken earned a bachelor degree from Hasanuddin University and a master degree from Gajah Mada University and also a doctorate degree from Ehime University, Japan. And she is a lecturer in Department of Forestry Faculty of Halu Oleo University. And she focuses her research on non-timber forest products such as resin, stainless bee products such as honey, propolis, and bee bread. Please play video number 307. IT team, please play video number 307.
Good afternoon, everybody. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the committee for time for me to explain our research entitled Characteristic and Quality of Puuti Damar Hopea gregaria Vesluten from Tahura Nipa-Nipa, Southeast Sulawesi. By me, Niken Puji Rahayu, Basrudin Sakia Oslinawati, Hayati Hajar and Budia Stuti, from Forestry Department, Faculty of Forestry and Environmental Science, Alu Oleo University. Introduction. Indonesia have a big rainforest, tropical rainforest, and some of the tropical rainforest is Dipterocarpaceae family. This family have about 506 species, including in 14 genera, and most of them, about 76%, grow in Malaysia region, like Indonesia, and in Sulawesi, like Southeast Sulawesi. One of species of this family is endemic in Sulawesi, Southeast Sulawesi, is Hopea gregaria. This tree produce a good quality and also produce a low wood material. It's like cat A damar or damar mata kucing in Indonesia. Is a damar resin from Dipterocarpaceae. Damar from this family is one of the superior products from non-timber forest products in Indonesia and also in the world. It's used in various industries, including paints, inks, varnishes, paints, pharmacy, and food additives. And previous research has shown that putty resin from trees with a diameter of 30 cm has a class 2 quality based on standard national Indonesia, while resin from potty trees with a diameter of 50 cm has no known quality. So this study aims to determine the characteristic and quality of resin from potty trees obtained from the 50 cm diameter in class. Material and methods. We use a damar resin from Hopea tree with diameter 50 cm. Then we make a tipping bar in size 10 cm times 10 cm and depth of 2 cm. Then we collect the resin, then crush in to application in to use it in visual testing and laboratory testing. Visual testing refers to Standard National Indonesia number 2900 2012. It consists of two parameters, color and size of chunks. Then we also conduct laboratory testing refer to Standard National Indonesia with number 2900.2 2012. 15. It consists of 5 parameters: acid number, as content, impurity level, turbidity intolerant solution, and softening point, with an ephemerometric turbidity unit in turbidity. Result from the visual testing, we get that the color of damar putih is clear yellow. This is a high quality the damar with a clear yellow color, and the size of chance from the oil sample is more than 3 times 3 centimeter, and it's based on standard national Indonesia is include to a grade. For the physical and chemical characteristics of putih based on standard national Indonesia, from the 5 parameter, impurity content is average 0.44. Its score is based on standard national Indonesia. It's included in first class. The softening point with average level 75, and it's including one class. Turbidity intolerant also in first class, as content with average 0.01 is also included in first class, but acid number is included in 1 to 2 class with average value 28.0. Toluene is an organic solvent that can dissolve resin so that the insoluble material in toluene solves the impurity level of resin. The higher impurity level worse the quality. Damar with low impurities will produce a low softening point value as well, and the lower the soft point, the better the quality class. Then in contrast, the higher soft point, the worse the quality class. And then we compare the putih resin quality and standard national Indonesia requirement for the 5 parameter. Only acid number is included 1 until second grade. In order is first class, first grade. Conclusion: the result of the visual test of resin from 50 cm diameter Hopea gregaria 3 included in the quality class A based on standard national Indonesia 2012 standard with a clear yellow color and lump size of more than 3 times 3 cm. At the same time, the test result of the physical and chemical characteristic of putih resin referred to standard national Indonesia 2016 obtained the average value of impurities content, soft point, turbidity intolerant, and ash content are in class 1, while the acid number is in class 1 to 2, so that the overall quality of the resin from Hopea gregaria is in class 1. And this result also saw that the quality of Hopea gregaria resin is equivalent to that of Soria javanica, which is known to have the best quality and provide a great opportunity for the use of this type of resin. Thank you very much.
Okay, thank you for Ms. Niken Bujirhayu for the presentation. So, do we have any question here, ladies and gentlemen? Yes, Pak Gunawan.
Thank you. Bu Niken, I want to know about the, as I know the damar mata kucing from Sorea javanica. Do you have any data about the differences between Sorea and Hopea? That's all. Thank you.
Thank you, Mr. Gunawan. Yes, after I read the research paper about Sorea javanica resin, it said that Sorea javanica resin or damar mata kucing is the high class from damar in Indonesia, and this resin from pooti tree in local name local pooti and Latin is Hopea gregaria. After we conduct some test for visual testing and laboratory testing, we find that the quality is equivalent with the Sorea javanica. But in Southeast Sulawesi, it's not yet collected by the people in the around forest around. This in the area is from Taman Hutan Rakyat Tahura Nipa. So maybe it's need to some research again to information about this potential from Hopea gregaria, because this we find until now is only found in South Sulawesi. It's almost the this endemic in South Sulawesi. Maybe find also in Maluku Island. Until now we know about that. So it's very interesting to do research in this tree, I think. Thank you.
Okay, thank you. So the source of damar mata kucing from genera Sorea and Hopea.
Yes.
Yes. Okay. Thank you. Thank you, Bu.
Yes. You're welcome.
Thank you, Pak Gunawan and Bu Niken. We can still have still have time for one more question. I offer to the audience. Is there anyone to ask question to Bu Niken? Okay. If there's if no other question, then thank you, Bu Niken, and we will move to the next presenter. It is from Lisna Evianti from Center for Standardization of Sustainable Forest Management Instrument. So she has her bachelor and master degree from Gajah Mada University, and then joined the Chemical Laboratory of Forest Product Research and Development Center until now. And the research interest focuses on chemical energy, non-timber forest product, and catalyst material. And she believed that one of the ways to enjoy life is to balance the work and life. Oh, sorry, it's a good connection with other people. Okay, IT team, please play video number 308.
Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for the opportunity for us to participate in the first International Conference of Lignocellulose in conjunction with International Symposium for Sustainable Humanosphere 2021. My name is Lisna Evianti from Center for Standardization of Sustainable Forest Management Instrument. On behalf of our team, I will give presentation briefly about our research. The title of this research is Synthesis of Biosilica from Bamboo Waste and its Application as an Adsorbent. This is our outline presentation. The first one is Introduction. It contains of background and purpose of this research. The second one is Materials and Method, contains of procedure of this research. And then the result and discussion. We will present about the data analysis and explanation. And then conclusion, its source summary, and of course acknowledgement. One of the main issues in the world is environmental pollution caused by several compounds produced from various human and industrial activity. Some of these compounds are dyes, volatile organic compounds, and methyl compounds. For example, iodine compounds released from antiseptic medicine, methylene blue from textile and cosmetic industries, chloroform, toluene, benzene, and ammonia usually as solvent industry. The excessive release of these compounds bring environmental and health damage. To remove this pollution, we have several techniques such as ion exchange, adsorption process, and biological treatment with microbial assistance. The reduction effort to remove dyes and volatile organic compounds in this research is by adsorption process. In this method, we need an adsorbent such as zeolite, carbon, or silica. As we know that Indonesia has a great number of biomass such as bamboo. This plant is a fast-growing species with limited utilization, especially leaf loss. Bamboo considered as a potential raw materials. It's renewable and abundant, which can be converted into valuable materials, such as adsorbent. Based on several research, bamboo leaf has a high content of silica. For this reason, we take action to contribute the removal pollution. The first step is with extraction process of silica from bamboo waste into silica for adsorbent materials, and second one is application its adsorbent for dyes and volatile organic compounds adsorption. After silica produced, we use it for adsorption process. This is several why. The first one, adsorption process is generally inexpensive and commonly used in many industries. There are two types of adsorption process, such as liquid with the same phase with between adsorbent and adsorbate, and solid adsorption with different phase. So the solid adsorption is easier to separate. The solid adsorbent derived from natural materials are expected to be non-toxic and non-corrosive approach. Several research before proved that silica from bamboo has a good potential to remove pollutant, and silica has a good chemical and thermal stability during the reaction process. It's also high surface area and low cost production. Therefore, in this research, silica extracted from bamboo leaf was then characterized and used as adsorbent for iodine, methylene blue, benzene, chloroform, toluene, and ammonia compounds. This is our materials and method. The first one is materials, consists of several chemical compounds. The second one is instrument analyzer. We use UVVs, SEM, surface area analyzer, FTIR, and XRF for characterize the materials. The third is equipment, several chemical glass and other support. And the last is method, including material preparation, extraction, and adsorption process. This is our research procedure. The bamboo leaf as a raw material was and dried and then burned in the conventional furnace for 40 degrees for until 5 hours until ash produced. After that, the ash material extracted with natrium hydroxide using reflux method, conducted at temperature of 80 degrees Celsius for 2 hours, with stirring continuously, then it filtered. The filtrate collected as natrium silica. The natrium silica then added with hydrochloric acid until neutral pH, then aging for 24 hours, followed by filtered and dry. After this process, the biosilica contained, characterized, and used for adsorption process. The biosilica characterized using FTR to determine functional groups contents, XRF to analyze silica and other elements, SEM for surface morphology, surface area analysis for surface area, pore volume, and pore size of biosilica. The application of this biosilica for iodine adsorption with titration method, ammonia chloroform, benzene and toluene adsorption using vaporization method, and methylene blue adsorption with spectroscopy method. This is our result and discussion. In general, silica contents of siloxane and silanol group in the surface. The functional groups spectra of this silica analyzed by FTIR. From this figure, we could see that there is several functional groups observed such as silanol, siloxane, and hydroxyl groups observed in the different wave number. This functional group usually important factor for adsorption process. The silica produced then characterized for the surface morphology using SEM, and based on the figure, the silica morphology observed as a irregular row shape and some of its aggregates. It's similar with previous research reported by Bunyak et al. From this research, there are several elements in silica produced from bamboo leaf loss. It's seen in the table 1. The silica elements is main compound in this material with concentration of 49.34% and also other elements contained in this material. This result higher than previous research reported by Hasri et al. Using hydrothermal method and similar with Lewin et al. That produced silica from bamboo leaf with 52% concentration. It means biosilica in this research tend to be impure because mixed with other elements, and it will affect the adsorption process. And then from the nitrogen adsorption, desorption graph, we could see that the silica isotherm follows the type 4 isotherm with hysteresis loop. The result of BFT calculations shows that the silica surface area is 572.833 meter quadrat per gram. The pore distribution of silica with an average pore size of 4.945 nanometers. And the pore volume of silica is 0.708 centimeter cubic per gram. This result higher than silica from sand, but smaller than silica from synthetic material. This one is the factor can affect the adsorption process is surface area. The higher of the surface area will give more active site and pore to absorb the adsorption. This is the adsorption result. From this figure, we could see that adsorption capacity of biosilica from bamboo is different for each other compound. The adsorption capacity of silica for toluene, chloroform, benzene, and ammonia is 2.55%, 14.22%, 15.7%, and 19.46% respectively. It is probably affected by several factors such as molecular size, solubility, and competition of volatile organic compounds and water vapor. The adsorption capacity for iodine is only 107.6 milligram per gram. It's still lower than other materials such as activated carbon. For methylene blue adsorption, the adsorption capacity is 70.28 milligram per gram with removal percentage of 58.56%. It's probably affected by electronegativity and molecular charge. As we know that methylene blue is positively charged, while biosilica in this research probably negatively charged. Because if we see with FTIR spectra, the silanol groups will deprotonated into siloxane group because this adsorption conducted in neutral pH. The adsorption process affected by several factors, including the properties of the adsorbent, such as surface area, morphology, element contents, and molecule charge, and property of adsorbent, such as molecule size, solubility, and molecular charge, as well as adsorption conditions such as pH, adsorbent dose, initial concentration, and contact time. So in further research, we need to analyze more deeply to analyze adsorbent properties, adsorbent properties, reaction condition, or maybe modification of surface properties. This is our conclusion. The results show that biosilica synthesis from bamboo leaf was with mesoporous type and high surface area consists of siloxane, silanol, and hydroxyl group on its surface. The silica contents in biosilica is 49%. The adsorption capacity of iodine, methylene blue, toluene, chloroform, benzene, and ammonia show different values, but we think that biosilica will be potential to develop as an alternative green adsorbent in the future. Author is expressing grateful to the technician of chemistry laboratory of Center for Standardization of Sustainable Forest Management Instrument and Japan Society for the Promotion of Science for providing partial funding of this publication. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, waalaikumsalam warahmatullahi wabarakatuh. Thank you, Bu Lisna. And do you have any question here? Bu Lisna cannot join the session, but we do have her co-author, Bapak Nur Adi Saputra. So if any one of you would like to address question, please.
I have question from
Bu
Mr.
Niken?
Mandiri. Yes.
Yes, please.
What kind or species of bamboo you used in this research? What species bamboo?
Yes, thank you, Bu Niken. We use bambu betung species, Bu Niken.
Bambu betung.
Yeah, bambu betung.
Only one species?
Yes.
Okay. Is leaf from you take it from the bamboo tree or you take from the ground?
Yes. We cut off the stem of bamboo and we collected the bamboo leaf freshly.
Oh, I think it's a good research.
Yes, thank you.
Because we also do some research about bamboo in Halu University. It's a good idea. Thank you.
We can have collaborate research.
Yes, I think it's a good idea for collaborate because we have many species bamboo in Sulawesi.
Okay, yeah.
Okay, thank you.
Thank you, Bu Niken.
Hi.
Okay. One more question, maybe one more short question before we end today's session.
Maybe I have one question.
Okay, please.
Pak Adi, Pak Nuradi, do you have any comparison with the bamboo trunk? I mean that do you have compare about the leaf silica content in the leaf or silica content in the trunk, and then how about the comparison? Thank you.
Thank you, Pak Danang. Actually, in this research, we don't compare to another species. Maybe in next research, we will compare to another species that commonly find in market. Thank you.
Okay, it's good enough, Pak Danang.
Okay, thank you.
Okay, ladies and gentlemen, now please give a big round of applause for every presenter and participant in this room who have stayed until this time. And now it's time for me to close our session. And I thank you very much for an interactive session. And we also will continue tomorrow on the second day of the first Icon-Lig and ISSH. The conference tomorrow will be open at 9:30. The link will be open at 9:30. And the conference will be start at 10. And you will find the link in your program book. And we understand that some of you may require the program book for your professional interest. Therefore, we will update the program book, especially for the authors, title, and abstract section following the final version of your paper that will be published in our Scopus Index proceeding. And we will send the program book by your registered email. So please kindly check it, especially at the beginning of October 2021. So before I close the session, are there any questions, Bapak Ibu? Okay, no? Thank you for the participation. We are looking forward to see you tomorrow and have a great rest of your day. Thank you, Bapak Ibu.
Thank you.
Thank you, Ms. Priwi.
Wassalamualaikum warahmatullahi wabarakatuh.
Thank you.
Thank you. See you tomorrow.
Thank you very much, moderator.
Thank you. Can I just remind you, if any one of you haven't done the fill in the attendance list, you can just go to the chat room and the link is there.
Okay, thank you.
Okay, thank you, Professor Herman.
Yeah.
Bapak Ibu, the session and the event is finished now. We don't need to go back to the main room. So you can just continue your activity for the day. And see you tomorrow.